There is a number that determines the fate of every human being who has ever lived, every civilization that has ever existed, and every creature that has ever looked up at the night sky and wondered what is out there. It is not a biological number, not a lifespan, or a generation time, or a mutation rate. It is not a political number, not a budget or a vote or a treaty. It is a physical constant, fixed by the laws of nature at the moment the universe came into existence, unchangeable by any technology or ingenuity or ambition that any civilization could ever develop. It sits at the heart of special relativity, embedded in the fabric of space-time itself, and it places an absolute ceiling on the speed at which any object, any signal, any piece of information can ever travel through the universe. The speed of light, 300,000 kilometers every second, about 1.08 billion kilometers per hour. Fast enough to circle the Earth 7.5 times in a single second. Fast enough to travel from the Earth to the Moon in 1.28 seconds. Fast enough to reach the Sun in 8 minutes and 20 seconds. And nowhere near fast enough to take us anywhere worth going. The nearest star to our Sun is 4.24 light-years away, traveling at the speed of light, which is physically impossible for any object with mass, but let's start there. It would take 4.24 years to arrive. The center of the Milky Way is 26,000 light-years away, 26,000 years at the speed of light. The Andromeda Galaxy, our nearest large galactic neighbor, is 2.537 million light-years away, 2.537 million years at light speed. The edge of the observable universe is 46.5 billion light-years away, 46.5 billion years at light speed, more than 3 times the current age of the universe. And we cannot travel at the speed of light. We cannot come close to it. The fastest spacecraft ever launched by humanity, the Parker Solar Probe at its closest approach to the Sun, reaches approximately 0.064% of the speed of light. At that speed, a journey to Alpha Centauri would take approximately 6,600 years, not a human lifetime, not a dynasty, not a civilization, a geological epoch. This is the prison, not a cage with bars you can see, not a wall you can touch, not a boundary that technology will eventually let you climb over. A prison built from the laws of physics themselves. A prison whose walls are the speed of light and whose dimensions are the distances between stars. A prison so large that the cell you're locked in, the Earth, the solar system, even the Milky Way, is unimaginably vast by any human standard, and yet hopelessly, permanently, irrevocably small compared to what lies beyond the walls. This video is about that prison, about what it is exactly and why it exists, about what the speed of light actually means physically, and why it is a limit rather than merely a current barrier, about what it would actually take to travel to other star systems, and why even proposed solutions, warp drives, wormholes, generation ships, either violate known physics, require energies that the entire civilization of Earth could never produce, or condemn the travelers to consequences worse than staying home. About what dark energy is doing to the prison walls, making them move outward faster than we can ever move, sealing galaxies beyond an event horizon from which no signal will ever return, and about what this means for the question of contact with other civilizations if they exist, the possibility that the prison is not just ours, but the universal condition of every technological species that has ever evolved anywhere in the history of the cosmos. The universe is not indifferent to us. Indifference would imply no relationship at all. The universe is something more specific than that. It is structured at the most fundamental level in a way that makes the distances between interesting things larger than any physically possible speed can bridge on any timescale relevant to a civilization. The prison is not accidental, it is baked in. Chapter 1: The Speed of Light. Why it's a limit, not a target. When most people encounter the speed of light as a limit, the instinctive reaction is to treat it the way earlier generations treated the sound barrier, as a practical engineering challenge that will eventually be overcome. The sound barrier was once thought to be a fundamental physical limit. Aircraft approaching Mach 1 experienced severe turbulence and control difficulties that engineers in the 1940s did not know how to solve. And then, in 1947, Chuck Yeager flew the Bell X-1 through the sound barrier in level flight, and within a decade, supersonic travel was routine. The speed of light is categorically, qualitatively, fundamentally different from the sound barrier. It is not an engineering challenge. It is a feature of the structure of space-time. Understanding why requires a brief excursion into special relativity. Not the mathematics of it, but the physical reality it describes. Einstein's special theory of relativity, published in 1905, begins from two postulates. The first is that the laws of physics are the same in all inertial reference frames, frames moving at constant velocity relative to each other. The second is that the speed of light in a vacuum is the same for all observers, regardless of their motion relative to the light source. This second postulate is the counterintuitive one. If you are on a train moving at 100 kilometers per hour and you throw a ball forward at 50 kilometers per hour, someone standing on the platform sees the ball moving at 150 kilometers per hour. The velocities add. But if you are on that train and you shine a flashlight forward, someone on the platform does not see the light moving at 300,000 kilometers per second plus 100 kilometers per hour. They see it moving at exactly 300,000 kilometers per second. The speed of light does not add. It does not change regardless of the motion of the source or the observer. This fact, confirmed by the UN Michelson-Morley experiment in 1887 and by every precision measurement made since, has specific and unavoidable consequences for what happens as an object approaches the speed of light. Three things happen simultaneously and inescapably. First, the object's relativistic mass increases. As an object accelerates toward the speed of light, its effective inertia, its resistance to further acceleration, increases without limit. The faster it goes, the harder it is to accelerate further. To reach the speed of light exactly, you would need to accelerate an object of any non-zero rest mass to infinite effective inertia, which requires infinite energy. This is not a problem that better engines solve. Infinite energy does not exist. The speed of light is therefore not a target that requires more powerful rockets. It is an asymptote that no finite amount of energy can reach. Second, time dilation occurs. As an object moves faster, time passes more slowly for it relative to a stationary observer. At 90% of the speed of light, time passes at about 44% of its normal rate from the perspective of a stationary observer, meaning a clock on the fast-moving object ticks at less than half the rate of a clock at rest. At 99% of light speed, the time dilation factor is about 7. Clocks on the fast-moving object tick at about 1/7 the normal rate. At 99.9%, the factor is about 22. At 99.99%, it is about 71. As you approach light speed, time for the traveler approaches 0. A photon, traveling at exactly the speed of light, experiences no time at all. For a photon, the entire lifetime of the universe is instantaneous. Third, length contraction occurs. Objects moving at high speed are contracted along their direction of motion. They are shorter in that direction from the perspective of a stationary observer. At 99.99% of light speed, an object 1 kilometer long in its rest frame appears to a stationary observer as only about 14 meters long. These effects are not illusions or measurement artifacts. They are real physical changes in the geometry of space-time. They have been measured directly and precisely. Time dilation is confirmed by the behavior of muons created in the upper atmosphere, which should decay before reaching the ground at non-relativistic speeds, but live long enough at relativistic speeds to be detected at sea level. By the slight but measurable difference in the rate of atomic clocks on aircraft versus on the ground, the GPS satellite system must account for relativistic effects to remain accurate. And by particle accelerators, where relativistic kinematics are the bread and butter of daily experimental life. The speed of light as a limit is not, therefore, a target that more energy might eventually reach. It is a structural feature of space-time, the universe's own geometry, that makes the concept of moving faster than light not merely difficult, but physically meaningless for objects with mass. A massive object cannot reach the speed of light for the same reason a square cannot have 3 sides. Not because of an engineering limitation, but because the concept is geometrically incoherent. The speed of light is the conversion factor between space and time in the geometry of space-time. It is the rate at which the spatial dimension converts to the temporal dimension in the 4-dimensional manifold that is the universe. Moving faster than light would be equivalent to moving backward in time, which generates causality violations, closed time-like curves that allow you to affect your own past, producing logical contradictions of the kind that most physicists take as evidence that the scenario is physically impossible. This is the first wall of the prison. It is not a wall you can break through. It is a wall that is made of the same stuff as the space on either side of it. There is no outside to the wall, and no outside to the prison. The universe does not have an exterior. Chapter 2: The Actual Numbers. What interstellar travel really means. Understanding that the speed of light is a genuine limit, not merely a current barrier, changes the calculation for interstellar travel in a specific and devastating way. Let us go through the actual numbers, not in the spirit of pessimism, but in the spirit of precision. If we are going to talk about the prison, we should be clear about its actual dimensions. The nearest star system to the Sun is Alpha Centauri, at a distance of 4.24 light-years, approximately 40.1 trillion kilometers. The current record for the fastest human-made object is the Parker Solar Probe, which at its closest approach to the Sun reaches approximately 192 kilometers per second, about 0.064% of the speed of light. At this speed, the journey to Alpha Centauri would take approximately 66,000 years. The Parker Solar Probe achieves this speed only by using the Sun's gravity in repeated close passes. It is not a sustainable cruise speed for an interstellar trajectory. Voyager 1, traveling at about 17 kilometers per second, its actual cruise speed through interstellar space would take approximately 73,000 years to reach Alpha Centauri if it were headed there, which it is not. These timescales are not incidental. They are the actual duration of the journey at current technology. 73,000 years is approximately the time since anatomically modern humans first left Africa in significant numbers. It is the entire duration of recorded human civilization from the earliest cave art to the present, multiplied by about 15. No human project has ever sustained coherent organization for anything approaching this timescale. The longest-running continuous institutions in human history, certain religious traditions, certain legal systems, are perhaps 3,000 to 5,000 years old. A 73,000-year journey would require an institutional continuity 50 times, longer than anything humanity has ever achieved. What about faster propulsion? Chemical rockets, the technology that has carried every human being and every spacecraft into space, are extraordinarily limited by the rocket equation. The Tsiolkovsky rocket equation states that the change in velocity achievable by a rocket is determined by the exhaust velocity of its propellant and the mass ratio of propellant to payload. Chemical rockets have exhaust velocities of around 3 to 4.5 kilometers per second. To reach even 1% of the speed of light, which would still require 424 years to reach Alpha Centauri, using chemical propulsion would require a mass ratio so enormous that the fuel mass would need to be on the order of 10 to the 29th power times the payload mass. For reference, the mass of Jupiter is approximately 2 times 10 to the 27th power kilograms. You would need more than the mass of many Jupiters of fuel to accelerate a small spacecraft to 1% of light speed using chemical rockets. Chemical propulsion is not a path to interstellar travel. Not in the future, not with better engineering. It is the wrong technology by many orders of magnitude. Nuclear propulsion is more promising in principle. Nuclear fission rockets using uranium or plutonium have specific impulses, a measure of fuel efficiency proportional to exhaust velocity, roughly 10 times higher than chemical rockets. Nuclear fusion rockets, which have been theoretically designed but never built, could achieve specific impulses perhaps 100 to 1,000 times higher than chemical rockets. The most ambitious nuclear propulsion concept that has been seriously engineered is Project Orion, a spacecraft propelled by the repeated detonation of nuclear bombs behind a massive pusher plate, which was studied in the 1950s and 1960s and found to be theoretically capable of achieving speeds of perhaps 3 to 10% of the speed of light, using a vehicle massing thousands of tons. At 10% of light speed, the journey to Alpha Centauri would take about 42 years. The same distance, 42 years, one way, with no return, using thermonuclear bomb detonations. At 10% of light speed, there is negligible time dilation. The journey takes 42 years for the traveler and 42.4 years for observers on Earth. So the traveler ages 42 years on the way out. They arrive at a star system they know almost nothing about. We have detected no confirmed planets at Alpha Centauri, though the search continues. Spend some time exploring, and then face a 42-year return journey if they want to go home. The traveler who left at age 30 returns at age 104, assuming they survive, to an Earth where their friends and family are dead, and the world has moved on by 85 years. This is the best-case interstellar scenario, using physics legal propulsion at the scale of engineering humanity could conceivably achieve. For more distant destinations, the numbers become impossible in a human lifetime. The center of the Milky Way, 26,000 light-years away. At 10% of light speed, a 260,000-year journey each way. At even 90% of light speed, requiring energy inputs that dwarf the output of the entire sun over its lifetime, a 28,900-year journey, with time dilation reducing the experienced time on board to about 12,600 years, still far beyond any individual human life, and well beyond any realistic institutional continuity. The Milky Way galaxy, at 100,000 light-years in diameter, is the cell of the prison that contains us. And even this cell is effectively uncrossable at any speed achievable by any technology currently conceived. The distance to Andromeda, 2.537 million light-years, is 25 times the diameter of the Milky Way, at 99% of light speed, requiring energy inputs completely beyond any conceivable human technology. The journey takes 2.537 million years in Earth time, with time dilation reducing the experienced time on board to about 357,000 years. Still, by any measure, a journey that would take longer than the entire fossil record of the genus Homo. The prison's dimensions, in other words, are not merely inconvenient. They are civilization-ending for any traveler who attempts to cross them. The distances are not large in the way that the distance from Europe to America was large in 1492, a challenge of months, solvable with better ships. They are large in a way that no technology can fully address, because the limit is not the engine, but the speed of light itself, and the distances are measured in light years. Chapter 3: Time Dilation, the Strange Mercy and the Cruel Catch. There is technically a loophole in the prison. Not a way out, but a way to experience the journey differently. Time dilation, which we discussed briefly in the physics section, offers a remarkable possibility. If you travel fast enough, time on the spacecraft slows relative to time in the rest frame of the universe. For a traveler at 99.9999% of the speed of light, the time dilation factor is approximately 707, meaning that for every 707 years that pass on Earth, only 1 year passes on the spacecraft. A traveler at this speed could, in principle, cross the entire observable universe, 93 billion light-years, in approximately 131 million years of ship time, while 93 billion years pass outside the spacecraft. This is technically a form of interstellar travel. The traveler genuinely arrives at a distant destination, having aged only a modest amount. But examine the catch more carefully, because it is catastrophic. First, You cannot come back in any meaningful sense. Earth time and ship time diverge. A traveler who leaves Earth at 99% of light speed travels to a destination 26,000 light years away and returns, arrives back on Earth having aged about 7,500 years in ship time, but having been gone 52,000 years in Earth time. The Earth they return to is not the Earth they left. In 52,000 years, human civilization has transformed beyond any recognition. The languages, the cultures, the nations, the technologies, the very genetic makeup of the population, all are unrecognizably different from the civilization the traveler departed. Every person they knew is not just dead, but has been dead for thousands of generations. The traveler is not returning home. They are arriving as a stranger with memories of a vanished past in a future they cannot understand or navigate. Second, the energy requirements for achieving sufficiently high fractions of the speed of light are extraordinary. Not merely expensive, but physically prohibitive. To accelerate a spacecraft of mass m to a fraction beta of the speed of light, the kinetic energy required is gamma minus 1, mc squared, where gamma equals 1 over the square root of 1 minus beta squared is the Lorentz factor. For beta equals 0.999, 99.9% of light speed, gamma is approximately 22.4. To accelerate a 1,000-ton spacecraft to this speed requires approximately 2 times 10 to the 24th power joules, roughly the total energy output of the Sun in about 6 days. To decelerate at the destination requires the same energy again. Acceleration and deceleration together require approximately the Sun's total energy output for 12 days for a single 1,000-ton spacecraft. This is not merely expensive. The total energy output of human civilization currently is approximately 6 times 10 to the 21st power joules per year. The energy required to send one 1,000-ton spacecraft to 99.9% of light speed is approximately 3,300 times the total annual energy output of human civilization. If we dedicated every joule of energy humanity produces entirely to the task, not powering cities, not growing food, not running hospitals, literally everything, it would take 3,300 years just to accumulate enough energy for one spacecraft's acceleration phase, and then another 3,300 years for deceleration. And this is for a 1,000-ton spacecraft, which is roughly the mass of a small apartment building. Not a colony ship, not a self-sustaining habitat. A small apartment building. Third, at relativistic speeds, the interstellar medium, the thin gas of hydrogen atoms that fills the space between stars, becomes lethal. In the reference frame of a spacecraft moving at 99% of light speed, the interstellar hydrogen atoms, which are moving toward the spacecraft at essentially the speed of light from the spacecraft's perspective, appear as high-energy particles equivalent to the radiation produced by a particle accelerator. The flux of these particles on the spacecraft hull would be biologically lethal within hours without shielding, and the shielding required to block this radiation would be both extremely massive and probably insufficient against the higher energy encounters at higher speeds. There are no tested or proven designs for radiation shielding adequate for relativistic interstellar travel. Fourth, at sufficient fractions of the speed of light, even collisions with individual hydrogen atoms, which at rest are essentially harmless, release enough energy to be destructive. At 99% of light speed, a collision with a single hydrogen atom releases energy equivalent to a cosmic ray particle, and the interstellar medium has approximately 1 hydrogen atom per cubic centimeter on average. The rate of such collisions on the frontal area of a spacecraft would be prodigious. Designing the leading face of a relativistic spacecraft to withstand this continuous bombardment is an unsolved engineering problem with no clear path to solution. Time dilation is therefore not a loophole in the prison. It is a curious feature of the prison's architecture that allows a traveler to experience the journey more briefly, but it does nothing to reduce the energy requirements, the radiation hazards, the deceleration problem, or the fundamental disconnection between the traveler's experience and the civilization they left behind. It is, at best, a way to experience the prison sentence more rapidly. It is not a way out. There is one more dimension of the return problem worth sitting with. Imagine a traveler who leaves Earth in the year 2200, travels to a destination 26 light-years away at 90% of the speed of light, spends 1 year exploring, and returns. The outward journey takes about 28.9 years in Earth time, but only about 12.6 years in ship time. The return takes the same. Total elapsed ship time, about 26 years. Total elapsed Earth time, about 59 years. The traveler who left at age 30 returns at age 56 to an Earth where 59 years have passed. Their children are older than they are. Their grandchildren are adults. The world has moved forward, politically, technologically, culturally, by 6 decades without them. This is the mild version, a destination only 26 light-years away, achievable in principle by sufficiently advanced propulsion. For destinations hundreds or thousands of light-years away, this disconnection becomes total. The traveler returns to a world that has no continuity with the one they left. The language may have drifted beyond recognition. The civilization may have transformed beyond identification. The friends, family, institutions, and culture they knew are not just gone, but ancient history. The act of returning is not returning at all. It is arriving in a foreign future, wearing memories of a vanished past. Chapter 4: Proposed Escape Routes, Warp Drives, Wormholes, and Why They Don't Work. The speed of light limit is well known, and over the decades since Einstein published Special and General Relativity, physicists and science fiction writers have explored various theoretical mechanisms that might circumvent it. The most discussed are the Alcubierre warp drive and traversable wormholes. Both are genuine solutions to the equations of general relativity, meaning that the mathematical structures they describe are not inconsistent with the theory. Both are also physically realized in ways that make them not just difficult, but almost certainly impossible in practice. The Alcubierre drive was proposed by Mexican physicist Miguel Alcubierre in 1994. It is based on a genuine insight. Special relativity forbids objects from moving through space faster than light, but general relativity permits space itself to move, and there is no speed limit on the motion of space. The expansion of the universe, for instance, can and does carry galaxies away from each other at speeds faster than light in a perfectly physics-legal way. because it is the space between them that is expanding, not the galaxies moving through space. Alcubierre proposed a space-time geometry in which the space in front of a spacecraft is contracted, while the space behind it is expanded, propelling the spacecraft forward without any object physically moving through space faster than light. The spacecraft sits in a warp bubble and is effectively surfed by the motion of space itself to any destination in arbitrarily short time. The mathematics of the Alcubierre metric are self-consistent. The geometry Alcubierre wrote down does not violate the equations of general relativity. But the physics required to produce this geometry is deeply problematic. The energy-momentum tensor required to generate the Alcubierre geometry includes large quantities of negative energy density, energy that is less than zero. Negative energy density does not appear to exist in any macroscopic, stable form in nature. Small amounts of negative energy density exist in specific quantum mechanical contexts. The Casimir effect, for instance, involves negative energy density between closely spaced conducting plates. But the amounts are tiny and not manipulable into the large structured configuration required for an Alcubierre bubble. Harold Sonny White at NASA's Johnson Space Center proposed modifications to the original Alcubierre geometry in 2011 that he claimed reduced the exotic energy requirements, and pursued laboratory experiments to look for microscopic space-time effects. The mainstream physics community received these proposals with significant skepticism, and subsequent analyses by Harold White and others did not demonstrate a path to macroscopic warp drive technology. The fundamental problem? That the geometry requires negative energy density in large amounts, remains unsolved and may be unsolvable within known physics. Even setting aside the exotic matter problem, the Alcubierre drive has a causality problem. The interior of the warp bubble is causally disconnected from the leading edge of the bubble, meaning the crew inside the bubble cannot steer it. They cannot send signals to the front of the bubble to adjust it, because those signals cannot travel faster than light within the bubble's interior, and the bubble's leading edge is moving faster than light. You cannot drive the car from inside the car. The warp drive requires being set up in advance from outside the destination, which somewhat defeats the purpose of a vehicle. Wormholes are the other canonical escape route. A wormhole, technically an Einstein-Rosen bridge, is a topological feature of space-time that connects two distant regions through a shortcut. You enter the wormhole at one location, transit through the tunnel, and emerge at a distant location, having traveled a much shorter path than the conventional distance between the 2 points. Wormholes are solutions to the Einstein field equations. They were first described by Einstein and Rosen in 1935 as a feature of the Schwarzschild metric for a black hole. The problem with wormholes is threefold. First, natural wormholes, if they exist at all, are unstable. The simplest wormhole solutions collapse almost instantly. Faster than light could traverse them, meaning you cannot get through before it closes. Second, keeping a wormhole open long enough to transit requires exotic matter with negative energy density, the same requirement that afflicts the Alcubierre drive. Kip Thorne and colleagues showed in 1988 that a traversable wormhole requires exotic matter at the throat to keep it from collapsing, and the amounts required are enormous. Third, There is no observational evidence that wormholes exist anywhere in the universe. Black holes are confirmed. We have images of the shadows of supermassive black holes in M87 and the Milky Way. And we have detected the gravitational waves produced by merging stellar mass black holes. But wormholes, which would require a very different type of space-time geometry, have no confirmed observational signatures. The deepest problem with both warp drives and wormholes is that both require exotic matter with negative energy density in macroscopic, controllable quantities, something that appears not to exist in nature, and that known physics provides no path to creating or accumulating. The known energy conditions of general relativity, the weak energy condition, the null energy condition, the dominant energy condition, are satisfied by all known forms of matter and energy. Exotic matter with negative energy density would violate all of these conditions. Specific quantum mechanical effects can produce local violations of energy conditions on microscopic scales, but there are quantum inequalities that limit how large and how long-lived these violations can be. They cannot be accumulated into the macroscopic negative energy densities required for warp drives or wormholes. In short, the proposed escape routes are not just engineering challenges. They require forms of matter and energy that appear not to exist. They require controlling space-time geometry at a level that implies a physics beyond our current understanding that might or might not permit the required operations. And our best current understanding gives no reason to think it will. The prison walls remain intact. Chapter 5. Generation Ships. The grim alternative. If faster than light travel is impossible and relativistic travel is energetically prohibitive, there remains one other theoretical path to reaching other star systems: the generation ship. The concept is straightforward in outline and harrowing in detail. A spacecraft large enough to house a self-sustaining human community travels at a speed achievable by some conceivable future propulsion technology, perhaps 1 to 10% of the speed of light, on a journey that takes hundreds or thousands of years. The people who set out on the voyage are not the people who arrive. Multiple generations live and die on the ship. The crew of the arrival are the distant descendants of the crew of the departure. The generation ship concept has a romantic frontier spirit appeal that its practical realities quickly dispel. Consider what a generation ship actually requires. At 1% of the speed of light, the journey to Alpha Centauri takes 424 years, at 10%, requiring energy inputs comparable to nuclear bomb. Propulsion and representing the extreme of what any conceivable near-future human technology could achieve. It takes about 42 years. Even at 10%, the technology to decelerate at Alpha Centauri is as demanding as the technology to accelerate from Earth. The spacecraft must carry everything necessary for deceleration as well as acceleration. The mass ratio problem, the fundamental scaling problem of rocket propulsion, applies just as ruthlessly to the deceleration burn as to the acceleration burn. But the deeper problem with a generation ship is not engineering. It is sociological and psychological. A generation ship is a closed ecosystem. It must recycle all air, water, and nutrients indefinitely, grow all its food, maintain all its technology, care for its sick and dying, educate its young, adjudicate its disputes, maintain social cohesion, and preserve the institutional purpose of the voyage across multiple generations of people who never consented to be on the ship. The people born on the generation ship did not choose to be there. They were born into confinement, a vessel perhaps a few kilometers long at most, hurtling through empty space, with no possibility of leaving. The sociological pressures on such a community are extraordinary. Every social tension that exists in isolated communities on Earth, the friction of enforced proximity, the conflict between authority and autonomy, the problem of maintaining purpose and meaning over generations, the risk of schism and factionalization, is amplified on a generation ship by the absolute impossibility of exit. There is nowhere to go. There is no neighboring community to travel to, no wilderness to escape into, no possibility of founding a splinter group that goes its own way. The ship is the totality of the social universe for every person born on it. The historical record of isolated communities on Earth offers cautionary data. Isolated island communities, cults, religious, intentional communities, remote polar expeditions, long-duration submarine deployments. All of these environments, far less extreme than a generation ship, produce characteristic patterns of psychological stress, social conflict, and institutional breakdown on timescales of months to a few years. Long-duration Antarctic expeditions, isolated for less than a year, with regular communication to the outside world and the psychological horizon of a definite return, produce measurable psychological deterioration in a significant fraction of participants. A 424-year voyage with no communication lag of less than years and no return prospect at all is not an extrapolation of these environments. It is a qualitative departure from anything in human experience. There is also the problem of drift. Over multiple generations, the institutional purpose of the voyage, the explicit goal of reaching another star system and colonizing a planet, must be preserved and transmitted to people who have no personal memory of Earth and no personal experience of the departure. In human societies on Earth, institutional purposes drift substantially over timescales of decades, let alone centuries. Religious traditions schism, political systems transform, languages evolve, values change. The generation 10 times removed from the founding crew of a generation ship may or may not retain the knowledge, the technology, the social organization, or the motivation to execute the arrival and colonization plan devised by people who died centuries before them. What happens if they don't? What if the descendants of the generation ship crew, 200 years into the voyage, decide they don't want to go to Alpha Centauri? They can't stop. They can't turn back easily. The fuel budget for a mid-course correction and return journey may not exist. They are committed, by the momentum of the ship and the irreversibility of the journey, to an arrival at a destination that means nothing personal to them, chosen by people they have never met, in a universe defined entirely by the walls of the ship they were born in. The generation ship is not a vehicle. It is a prison within the prison, a sub-cell inside the larger cell of the solar system, moving very slowly through the vast cell of the galaxy. Chapter 6. The Dark Energy Wall. The prison is getting bigger. So far, we have discussed the prison in static terms, the distances between stars and galaxies as fixed, and the speed of light as a fixed limit that makes those distances essentially uncrossable. But the universe is not static. The universe is expanding. And the expansion is not just making everything farther away, it is accelerating. And the acceleration has a consequence for the prison that is, in some ways, more disturbing than the speed of light limit itself. Dark energy, the mysterious energy component that currently constitutes approximately 68% of the total energy density of the universe, and is driving the accelerating expansion, is making the prison walls move outward faster than the speed of light. Not the walls of the Milky Way, which is gravitationally bound and not expanding. Not the walls of the local group, which is also gravitationally bound. But the walls of the accessible universe, the boundary beyond which we can never send a signal or receive information, are defined not by the edge of what physically exists, but by the edge of what the expansion of space allows us to reach. This boundary is the cosmic event horizon. It is the distance beyond which, given the current rate of acceleration, no signal sent today will ever arrive, because the expansion of space between us and that boundary is carrying the boundary away faster than any signal can travel. The cosmic event horizon currently sits at approximately 16 billion light-years from Earth. Any galaxy closer than 16 billion light-years is, in principle, reachable by a signal sent today, though the signal might take billions of years to arrive. Any galaxy farther than 16 billion light-years is permanently unreachable. No signal sent from Earth today will ever cross that distance, because the expanding space will carry the destination farther away, faster than the signal can close the gap. This is already a significant constraint on the prison's accessible volume. But it gets worse. Because the expansion is accelerating, the event horizon is getting closer over time in terms of the number of galaxies it contains. Galaxies that are currently inside our event horizon, and therefore currently reachable in principle, will be carried outside the event horizon as the expansion accelerates, severing our causal connection to them permanently. This is not a slow process. Over the next few billion years, many of the galaxy clusters and superclusters currently visible to us will be carried beyond the event horizon. Their light will take longer and longer to reach us, redshifting toward infinity as the recession velocity approaches and eventually exceeds the speed of light. Eventually, their light will stop arriving entirely. They will fade from the sky as if they never existed. An observer in our galaxy 1 trillion years from now will see an entirely different sky. The CMB will have cooled beyond detectability. The distant galaxies of the current observable universe will all have receded beyond the event horizon. The visible universe, the prison cell, as experienced by our distant descendants, will contain only the local group, a few tens of billions of stars in a bounded cluster, surrounded in every direction by an expanding void of infinite apparent extent. From the inside of the prison, 1 trillion years from now, the universe will appear to consist of a single galaxy cluster, floating in an otherwise empty, dark, cold universe. The evidence that the universe once contained hundreds of billions of galaxies, the CMB, the redshift surveys, the deep field images, will all have faded. An astronomer living then, discovering physics from scratch, would have no observational basis for the Big Bang, no evidence of the cosmic web, no indication that anything exists beyond the local group. The information will be gone. The dark energy wall is, therefore, not just a current constraint on the prison. It is a constraint that is actively tightening. not on human timescales, within a human lifetime, within recorded history. Within the lifespan of human civilization as it has existed so far, the accessible universe changes negligibly. But on the time scale of the universe's future history, the accessible volume is shrinking, and the shrinkage is irreversible and permanent. The universe is not just big enough to trap us. It is arranged through dark energy to ensure that the trap gets progressively smaller over time. This has a specific implication for the Fermi paradox, the question of why we do not see evidence of other technological civilizations. That is worth noting here. If other civilizations exist in galaxies that are currently within our event horizon, the window during which we could potentially communicate with them is finite and closing. A radio signal sent today toward a galaxy 10 billion light years away will arrive in approximately 10 billion years. But by that time, the recession of that galaxy may have carried it beyond the event horizon, and any reply will never reach us. The window for two-way communication across the largest observable distances is already essentially closed by the accelerating expansion. The universe is not just too large for convenient communication. It is arranged so that the time window for such communication is finite and shrinking. Chapter 7: The Solar System as a Habitat, Learning to Love the Cell. Having described the prison in detail, the speed of light limit, the actual travel times, the failure of proposed escape routes, the generation ships, sociological nightmares, and the tightening of the dark energy wall, it is worth stepping back and asking a different question. Not, how do we escape? But what is the actual extent of the cell? And is it as limiting as it first appears? The solar system extends depending on how you define its boundary, from the sun to the heliopause at about 100 astronomical units, or to the Oort cloud at perhaps 200,000 astronomical units. Within this volume, which is enormous by any human standard, there are resources, environments, and physical space that dwarf everything humanity has ever used or explored. Mars is approximately 225 million kilometers from Earth at average opposition. A human journey to Mars using conventional chemical propulsion takes approximately 7 to 9 months one way. This is within the realm of human endurance. The record for continuous human spaceflight is 437 days, set by Valery Polyakov on the Russian Mir space station in 1994-95. Mars has a solid surface, some geological activity, polar, ice caps containing water ice and carbon dioxide ice, and is the most Earth-like environment beyond Earth in the solar system, though still very hostile to unprotected human life. With an atmospheric pressure about 0.6% of Earth's, temperatures ranging from -80 to about 20 degrees Celsius. High radiation exposure from cosmic rays and solar energetic particles, and no liquid water on the surface. The asteroid belt contains an estimated 1.1 to 1.9 million asteroids larger than 1 kilometer in diameter, and vastly more smaller ones, with a total mass of about 4% of the Moon's mass. They are composed of silicate rock, metal, primarily iron and nickel, and various carbonaceous and volatile rich materials, and they represent a resource base of staggering abundance. Effectively unlimited quantities of metals and minerals compared to anything available on Earth's surface. The outer solar system, the moons of Jupiter and Saturn, contains some of the most interesting environments in the solar system outside Earth. Europa, one of Jupiter's 4 large moons, has a global liquid water ocean beneath its ice shell, maintained by tidal heating from Jupiter's gravitational influence. The ocean is estimated to contain perhaps twice as much liquid water as all of Earth's oceans combined. Enceladus, a small moon of Saturn, has an active liquid water ocean venting water vapor and organic molecules into space through geysers at its south pole, detectable and sampled by the Cassini spacecraft. Titan, Saturn's largest moon, has a dense atmosphere of nitrogen and methane, with lakes and seas of liquid methane on its surface, the only environment beyond Earth where stable surface liquids exist. Ganymede and Callisto, also moons of Jupiter, may have subsurface liquid water oceans as well. These environments are not Earth. None of them are suitable for unprotected human habitation. Traveling to them takes months to years with conventional propulsion. But they are accessible in a way that other star systems are not. They are reachable on timescales of years to decades, with technology that is an extension of what already exists. They represent the actual accessible frontier, not other stars, not other galaxies, but the extended neighborhood of the solar system, a volume of space containing extraordinary diversity of environment and essentially unlimited resources, reachable within human lifetimes. Within the solar system, the prison becomes a different concept entirely. The cell is not a bare room. It is an enormous, resource-rich, environmentally diverse volume of space, most of which humanity has never visited and none of which has been systematically exploited. The solar system is, by the standard of everything humanity has ever actually needed, essentially infinite. It contains enough raw materials, enough energy from the sun, and enough environmental diversity to sustain a human civilization of incomprehensibly large scale, essentially indefinitely. A Dyson sphere, a theoretical megastructure that captures all of the sun's output, would provide approximately 3.8 times 10 to the 26th power watts of power. The current total energy consumption of human civilization is approximately 1.8 times 10 to the 13th power watts. A fully exploited solar energy budget is approximately 20 trillion times larger than humanity's current total energy use. The solar system is not a cell. It is a continent. It is a planet. It is an entire universe of possibility, compared to the surface of one world on which 8 billion people currently crowd. The prison metaphor is real at the scale of the stars. At the scale of the solar system, the metaphor inverts. We are not prisoners trying to escape from a cell. We are inhabitants who have barely stepped outside our front door. And yet, and this is the tension that this entire video has been building toward, the solar system is not the end of the story. The fact that the solar system is large enough to sustain any civilization we could practically imagine does not dissolve the existential weight of the speed of light limit, because the question is not merely whether we have enough room. The question is whether we are alone in that room, whether the prison is ours alone or shared, whether there are other civilizations equally imprisoned in their own solar systems, equally unable to cross the distances between stars, and what that implies about the possibility of contact, communication, and the ultimate fate of intelligence in a universe that, for all its vastness, has built its architecture around the principle of isolation. Chapter 8: The Fermi Paradox Revisited. Are all civilizations imprisoned? In 1950, the physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory when the conversation turned, as it occasionally did in the post-war years of nuclear anxiety and science fiction enthusiasm, to the question of extraterrestrial intelligence. Fermi's colleagues were discussing the possibility of faster-than-light travel, the likelihood that alien civilizations existed, and the plausibility that some might have visited Earth. Fermi listened, thought for a moment, and then asked a question that has defined the field ever since. Where is everybody? The question was deceptively simple and devastatingly precise. The galaxy is approximately 13 billion years old. Stars like the Sun have been forming for most of that time. If even a small fraction of those stars host planets, and if even a small fraction of those planets develop life, and if even a small fraction of that life develops intelligence, and if even a small fraction of that intelligence develops technology, the galaxy should, given 13 billion years and the sheer number of opportunities, be teeming with technological civilizations. Some of them should be millions of years more advanced than us. A civilization millions of years ahead of humanity, with the resources of an entire star system or multiple star systems at its disposal, should have had plenty of time to spread through the galaxy, even at sublight speeds, even with generation ships, even at a tiny fraction of the speed of light. A civilization that expands steadily can colonize the entire Milky Way in well under 1 million years. The galaxy is 100,000 light-years across. Even at 0.1% of the speed of light, a colonization wavefront would cross it in 100 million years, a geologically short time against the 13 billion year age of the galaxy. And yet we see nothing. No alien signals, no megastructures, no evidence of cosmic engineering, no visitors. The sky is silent and empty. Where is everybody? This is the Fermi Paradox, and it is genuinely one of the deepest unresolved questions in science. But the prison of the universe, the speed of light limit and the actual travel times it implies, is one of the most physically grounded potential resolutions to it, and it is not discussed as often or as carefully as it deserves. Consider the actual constraints that the speed of light places on interstellar communication and colonization. We have already established that travel to even the nearest star requires thousands to tens of thousands of years at any speed achievable by realistic technology. But the Fermi Paradox's colonization argument assumes that once a civilization develops interstellar travel, it expands. It sends ships to nearby stars. Those colonies establish themselves and send ships to their nearby stars, and the expansion propagates as a wave through the galaxy. The question is whether this expansion scenario is realistic, given the actual physics and sociology. If the minimum travel time between adjacent stars is, say, 1,000 years, an aggressive optimism for near-future propulsion technology, and if each colony needs, say, 10,000 years to establish itself before it can mount its own interstellar expeditions, then the expansion wave front moves at roughly one star system every 11,000 years. The Milky Way contains approximately 300 billion stars distributed through a disk 100,000 light-years across. At this rate, colonizing the galaxy takes on the order of 1 billion years, very long even by galactic standards, but short compared to the 13 billion year age of the galaxy. So the Fermi paradox's colonization argument survives even with realistic travel times, in principle. But here is what the prison argument adds that the naive colonization wave argument misses: the social and institutional fragility of the project. Each interstellar colony is not a replica of its parent civilization. It is a group of descendants of the founders, separated by thousands of years of travel and light-year distances of communication lag, evolving independently in a new physical environment. After 1,000 years of independent development, a colony is not an outpost of the home civilization, it is a new civilization. After 10,000 years, it shares ancestors, but not culture, language, technology trajectory, or values with its origin. After 100,000 years, the connection is purely genealogical, like the connection between a modern French citizen and a Cro-Magnon cave painter. The expansion wave, therefore, does not propagate as the output of a single unified civilization with a coherent purpose. It propagates, if it propagates at all, as a series of independent local decisions made by successor civilizations that have diverged substantially from their ancestors. Some of those successor civilizations may choose to expand further, others may not. Others may collapse entirely in the harsh, resource-limited, politically fragile environment of an isolated interstellar colony. Collapse is arguably the more likely outcome than sustained expansion. The sociological momentum of expansion is not guaranteed to persist across the distances and timescales involved. This gives us a resolution to the Fermi paradox that does not require any of the exotic assumptions of the more dramatic proposed solutions. No great filter, no cosmic quarantine, no inevitable self-destruction of technological species. The resolution is simply this: the speed of light makes interstellar travel so difficult, so slow, and so socially disruptive that civilizations do not expand through the galaxy in the coherent, purposeful way the naive Fermi argument assumes. They may attempt it. They may send probes, even ships. But the expansion wave front does not propagate at the pace the calculation suggests, because the civilizations on the wave front are not motivated, organized, or stable enough to keep pushing outward. The galaxy is quiet not because no technological civilizations exist, but because the prison is universal. Every civilization that arises is, as we are, trapped by the speed of light in its home system, able to explore its local neighborhood but unable to fill the galaxy in any civilizationally continuous sense. This does not eliminate all versions of the Fermi paradox. It does not explain why we do not see megastructures, why we do not see directed energy signatures of propulsion systems, why the sky is entirely dark in the radio frequencies that interstellar communications might occupy. These observations remain puzzling even under the prison hypothesis. But it does substantially deflate the strongest form of the argument: the claim that if any technological civilization exists anywhere, the galaxy should by now have been colonized end to end. Given realistic physics and realistic sociology, the galaxy can remain largely uncolonized, even with multiple technological civilizations. The prison is effective enough to keep everyone in their cell, more or less, for the relevant timescales. If this resolution is correct, then every technological civilization that has ever arisen in the Milky Way, every species that developed fire. Then, tools, then physics, then rockets, then the realization that the stars are other suns with their own planets, has arrived at exactly the point where we now stand. They looked up at the sky, they measured the distances, they derived the physics, and they found the same number we found: 299,792,458 meters per second. And they understood, as we are now understanding, that the number means they are alone. Not alone in the universe, alone in any operationally meaningful sense, alone in the sense that no other civilization will ever arrive at their doorstep, and they will never arrive at any other civilization's doorstep within any time frame that matters to the civilization as a living, continuous entity. If this is true, the prison is the universal condition. Every mind that has ever achieved sufficient complexity to ask the question, "Is anyone else out there?" has been simultaneously receiving the same answer. Yes, almost certainly. But you will never meet them, and they will never meet you, because the universe was built at a scale that defeats the speed at which anything can move through it. There is a version of this that goes even further. The civilizations that are furthest along, the ones that have had billions of years to develop beyond our current level, may have long since abandoned the project of interstellar expansion, not because the physics defeated them, but because they understood the physics deeply enough to recognize that expansion was not the point. A civilization that has had 1 billion years to develop computationally, cognitively, and philosophically may have concluded that the relevant frontier is not physical space, but something else entirely. The depth of understanding of the universe they already inhabit, the richness of the inner life they can construct within the physics available to them, the complexity of the mathematical and artistic and experiential territory that does not require leaving the home star system to explore. From this perspective, the silence of the sky is not a mystery requiring a dramatic explanation. It is what you would expect to see if the most advanced civilizations have all independently concluded, after sufficient development, that the universe is more interesting from the inside than from the outside, that the cell, properly explored, is richer than the corridor beyond it could ever be. The silence may be the sound of civilizations that have stopped looking outward and started looking inward, not in defeat, but in understanding. Chapter 9: What we can reach. The light cone and the shape of accessible space-time. The speed of light limit is not just a constraint on physical travel. It is a constraint on causality itself, on which events in the universe can affect which other events. Understanding the shape of this constraint gives us a precise picture of what is and is not accessible to us, now and forever, given the laws of physics as we know them. In space-time, the 4-dimensional fabric of the universe, 3 spatial dimensions plus time, every event has a light cone associated with it. The light cone is a geometric structure. Imagine a cone with its apex at the event in question, opening upward into the future. The surface of the cone represents the path of light signals emanating from the event in all directions. Everything inside the cone, in the future, can in principle be reached by or affected by the event, because a signal or object moving at or slower than light could arrive there from the event. Everything outside the cone is causally disconnected from the event. It cannot be reached by any signal from the event, and nothing that happened there can affect the event. The surface of the cone is the boundary between causally connected and causally disconnected regions. Every human being alive today exists at a particular event in space-time. The future light cone of that event, the region that our choices, our actions, our signals can potentially reach, defines the totality of what we can ever affect. Outside our future light cone, nothing we do matters. We cannot reach those regions, cannot affect them, cannot communicate with them, and they cannot affect us. The light cone is the true boundary of the prison, not just for physical travel, but for causation itself. Now consider what our future light cone actually contains. Moving forward at the speed of light, the boundary of our future light cone expands at 300,000 kilometers per second in every direction. After 4.24 years, it has reached Alpha Centauri. After 26,000 years, it has reached the galactic center. After 2.537 million years, it has reached Andromeda. After 46.5 billion years, it has reached the edge of the observable universe as it currently stands. The future light cone is vast. It eventually encompasses the entire observable universe and, given enough time, potentially much more. But the future light cone as defined by special relativity in a flat, non-expanding space-time is not the same as the future light cone in our actual universe, which is expanding and accelerating. Dark energy changes the shape of the accessible future. Because space is expanding at an accelerating rate, light cones in our universe do not expand to encompass everything indefinitely. Beyond the cosmic event horizon, currently about 16 billion light years, the recession velocity of space exceeds the speed of light, and our future light cone never reaches those regions. In an accelerating universe, the causal future is not the entire future of space-time. It is a finite region, bounded by the event horizon, that contains only a fraction of the universe's matter and structure. This has a specific implication for the question of what we can ever affect, ever communicate with, or ever travel to. The accessible universe, the region within our future light cone, even given infinite time, is not the observable universe. It is smaller. The observable universe is defined by what we can currently see. Radiation that has reached us from regions up to 46.5 billion light years away. The accessible universe is defined by what we can ever reach or influence. Regions within the event horizon, currently about 16 billion light years. The difference between these two is the region we can see but can never affect. The outer shell of the observable universe, which is already causally severed from us, even though its light is still reaching us. Within the accessible universe, the region inside our event horizon, there are approximately 10 to 20% of the 2 trillion galaxies of the observable universe. These galaxies, representing perhaps 200 to 400 billion galaxies, are in principle reachable or influenceable by signals sent from Earth given enough time. In practice, the time required to send a signal to the farthest of them and receive a reply is billions of years, far exceeding any timescale relevant to human civilization. But they are not causally severed. The remaining 80 to 90% of the observable universe, the galaxies beyond 16 billion light years, are already causally severed from us. and the severed fraction is growing as dark energy continues to accelerate the expansion. The light cone gives us the clearest picture of what the prison actually is. The prison is not just the solar system, not just the galaxy, not even just the local group. The prison is the future light cone, the entire region of space-time that we can ever affect or be affected by. And that region, while large in absolute terms, is finite, bounded, and shrinking in practical terms as the expansion of the universe carries more and more of it beyond our reach. We are not merely prisoners in a cell. We are prisoners in a cell whose walls are, slowly but inexorably, closing in. Chapter 10: The Psychological Prison. What permanent confinement means for a civilization. The physical prison of the speed of light has a psychological dimension that is rarely discussed but is deeply important. Knowing that you're confined, that the escape routes do not exist, that the walls cannot be climbed, that the distances are not just large but physically uncrossable in any meaningful sense, changes the psychological relationship between a civilization and the cosmos in ways that are not trivial and not yet fully reckoned with. For most of human history, the horizon was a practical barrier, not a physical law. The ocean was not crossable until the technology of navigation made it crossable. The poles were unreachable until the technology of polar exploration made them reachable. The sky was inaccessible until the technology of aviation made it accessible. The moon was untouchable until the technology of rocketry made it touchable. In every case, the barrier was an engineering challenge, something that ingenuity and resources could overcome. The psychological posture that naturally accompanies this history is optimism, the confidence that every barrier is ultimately surmountable, that the frontier always opens if you are persistent and inventive enough. The speed of light limit breaks this pattern entirely. It is not an engineering challenge. It is a law, as firm and as immovable as the law that the angles of a triangle must sum to 180 degrees in flat space. No amount of ingenuity changes the physics. No breakthrough in propulsion, no advance in materials science, no accumulation of resources brings the stars within reach on human timescales. The frontier of the interstellar, unlike the frontier of the ocean, the poles, the sky, and the moon, does not open with persistence. It simply does not open. This is a genuinely new psychological situation for our species, and it has only become fully apparent in the last century. Since special relativity gave us the speed of light limit, and subsequent astrophysics gave us the precise measurements of the distances involved, for most of human history, the stars were simply far away in an unquantified sense. They were remote, but the idea that they might be permanently inaccessible was not something anyone had worked out from first principles. The ancients who looked at the stars did not know that Alpha Centauri was 40 trillion kilometers away, that even the nearest star would require tens of thousands of years to reach at any realistic speed, that the galaxy was 100,000 light years in diameter. They saw lights in the sky and imagined reaching them, and the imagining was not constrained by physics because the physics was unknown. We are the first humans to know the actual number. We are the first to have done the calculation and found the answer. And the answer is, we are stuck here. How does a civilization metabolize this knowledge? How do individuals who are aware of it carry it? There are several patterns, and none of them are entirely adequate. The first is denial, a refusal to take the physics seriously, maintained by the persistent optimism that a breakthrough will come. Faster than light travel will be discovered. Wormholes will be engineered. The calculations are wrong or incomplete. This response is emotionally understandable. The alternative is a confrontation with permanent confinement. But it is intellectually dishonest. The speed of light limit is not a provisional result. It is built into the structure of space-time itself, confirmed by a century of precision measurements, and embedded in the most successful physical theory ever developed. Waiting for a breakthrough that overturns it is not optimism. It is denial dressed in the language of hope. The second is acceptance, the philosophical integration of the limit as a feature of reality rather than a problem to be solved. This is the healthier response, but it requires a significant reorientation of what space exploration means. If the stars are unreachable, then the purpose of space exploration is not colonization of other star systems, but the exploration and utilization of the solar system, a vast and incompletely understood environment that offers, within the prison, essentially unlimited room for civilizational growth. The solar system contains enough resources, enough energy, and enough environmental diversity to sustain a human or post-human civilization of unimaginably large scale. The cell is not comfortable by current standards, but it is not inadequate. It is simply bounded. And bounded does not mean small. The third is a kind of cosmic mourning, a genuine grief at the knowledge that the universe is too large for us, that the stars seen in every clear night sky are not destinations, but permanent decorations, objects of knowledge and beauty, but not of arrival. This response is not irrational. The stars are beautiful and the distances are real, and the prison is genuine. And there is something authentically sad about the specific form of the sadness. A species evolved to explore, to expand, to reach beyond the current horizon, permanently confined by the physics of its own universe to a single stellar system. The mourning is appropriate. It is proportionate. It is the correct emotional response to a correct understanding of the situation. What is not appropriate is letting the mourning collapse into nihilism, into the conclusion that because we cannot reach the stars, nothing within our reach matters. The prison does not empty the cell of meaning. It locates the meaning, places it precisely and definitively within the boundaries of what is accessible. The Earth is where we live. The solar system is where we can go. The Milky Way is what we can study through instruments, with light that crosses the galaxy in the time it takes to climb a mountain. The observable universe is what we can know through physics and mathematics, even without visiting it. These are not consolation prizes. They are the actual scope of our existence, and they are extraordinary. There is also a generational dimension to this that rarely gets acknowledged. The knowledge of the prison is new. It has existed in its fully quantified, physics-grounded form for about a century. There have been perhaps 4 or 5 human generations since the full scale of the problem became clear. Since stellar distances were accurately measured, since special relativity was confirmed, since the speed of light was established as an absolute limit rather than a practical barrier, since the distances to galaxies were measured and the scale of the observable universe became known. 4 or 5 generations is not very long for a species to metabolize a paradigm-shifting piece of information about its own situation. We are, as a civilization, still in the early stages of absorbing what the prison means. The first generation to know about it was in many ways too early. The knowledge was raw, without context. Without the supporting framework of exoplanet science or astrobiology, or the detailed understanding of the solar system's richness that we now have. They knew the walls were there, but did not have a full picture of what was inside. We are the first generation to simultaneously know the walls are uncrossable and know in meaningful detail how rich the interior is. That combination, constraint known precisely, contents understood richly, is what makes the present moment uniquely equipped to begin the genuine metabolization of the prison as a feature of reality rather than a problem to be solved. The psychological prison, the knowledge of confinement, is perhaps the most important intellectual challenge that the 21st century has presented to the human species. We are the first generation to fully understand the dimensions of the cell. We are the first to have measured the walls with precision, confirmed their nature with physics, and reckoned with the permanence of the confinement. What we do with that knowledge, whether we metabolize it into wisdom or let it fester into despair, is one of the defining challenges of the age. Chapter 11. The speed of light as a feature, not a bug. What the limit might protect. There is a perspective on the speed of light limit that rarely appears in discussions of interstellar travel, and it deserves serious consideration. The possibility that the speed of light limit is not a misfortune imposed on civilizations by an indifferent universe, but a structural feature that serves functions, perhaps essential functions, for the long-term existence of complexity in the cosmos. This is not a comforting argument in the sense of making the prison feel smaller. It is a different kind of argument, one that asks what the universe would look like without the limit, and whether that alternative universe would actually be better for the existence of life and civilization. Consider first the causal structure of the universe. The speed of light limit is fundamentally what makes the universe causally coherent. In a universe without a maximum speed, a universe where information could travel instantaneously or at arbitrary speeds, causality breaks down. You can construct scenarios where effects precede causes, where a civilization can send a message back in time to prevent its own existence, where the logical structure of before and after becomes ambiguous. Physicists call these causality violations, and they produce logical contradictions of the kind that suggest the scenario is not merely exotic, but actually incoherent. A universe without a speed limit may be a universe that cannot consistently exist. The speed of light is therefore not just a speed limit. It is the mechanism by which the universe maintains causal consistency, the orderly relationship between cause and effect that makes physics possible in the first place. A universe in which information can travel faster than light is a universe where the laws of physics, as we understand them, break down. It may not be a universe in which consistent physical law exists at all. The speed of light limit, from this perspective, is not a cage, but a foundation, the structural element that makes a coherent, law-governed universe possible. Second, consider the implications of faster-than-light travel for civilizational conflict. Humanity has a long and consistent history of violence, of civilizations that, upon contact with other civilizations, frequently attempted to dominate, exploit, or destroy them. The history of colonialism, of great power conflicts, of religious wars, of genocides. This is the record of what technologically sophisticated civilizations do when they encounter weaker ones or compete over resources. Now imagine a universe in which faster-than-light travel exists, in which a civilization on one side of the galaxy can reach a civilization on the other in days or weeks. The isolation that the speed of light currently enforces between civilizations would be eliminated. Every civilization would be a neighbor of every other civilization, in the sense that an aggressive or expansionist one could reach any other in a short time. In such a universe, a single aggressive, expansionist civilization that developed FTL travel first would have an extraordinary first-mover advantage. It could, in principle, spread to every star system in the galaxy before any other civilization could prepare a defense. The universe would be winner-take-all in a way that our universe, with its light-speed limited travel, is not. In our universe, even if an aggressive civilization wanted to colonize the galaxy, the time required to do so, thousands of years for each star system, hundreds of millions of years to spread across the full disk, gives every other civilization time to develop, time to adapt, time to prepare, or simply to diverge into something the aggressor cannot recognize or effectively target. The speed of light limit is, in a very specific sense, the universe's mechanism for preventing totalitarian domination of the entire galaxy by a single, rapidly expanding civilization. This argument has a speculative character. We do not know what other civilizations would do with FTL travel, any more than we know what our own civilization would do. But the point is that the speed of light limit is not obviously bad for the diversity and long-term existence of complex civilizations in the universe. It may be, there is no way to know, a feature of the universe's architecture that is actually protective of the kind of diversity and independence that makes a rich, complex, cosmic community of civilizations possible at all. Third, the speed of light limit preserves information. Because no signal can travel faster than light, the universe maintains a strict record of what has happened where. Causally disconnected regions of the universe evolve independently, without the kind of instantaneous correlations that faster-than-light communication would produce. The independence of distant regions, the fact that what happens in a galaxy 10 billion light-years away cannot instantly affect what happens here, is what allows the universe to develop the enormous diversity of structure and history that we observe. In a universe with instantaneous communication, the entire cosmos would be immediately correlated. Every event would propagate its influence to every other point instantly, producing a kind of universal homogeneity. The rich variety of structures that have developed independently in causally disconnected regions of the universe, the different evolutionary histories of different galaxies, different planetary systems, different biospheres, would be impossible. The speed of light limit is the mechanism by which the universe maintains the independence of its parts. And that independence is what allows diversity to exist and persist. None of this makes the prison more comfortable or the distances shorter. The stars remain unreachable, and the walls remain real. but it reframes the prison in a way that is at least intellectually honest about the full picture. The speed of light limit is not just something that prevents us from reaching other stars. It is the same physical constant that makes the universe causally coherent, that may protect civilizational diversity, that preserves the independence of cosmic structures. The prison is also the foundation of the world inside it. You cannot remove the walls without also removing the floor. Chapter 12. The Strange Comfort of the Cell. Learning what the prison actually contains. Every description of the prison so far in this video has been outward-looking. The distances between stars, the speed of light limit, the dark energy wall, the Fermi paradox, the tightening of the accessible universe. All of these are descriptions of what lies beyond the cell's walls and why the walls cannot be crossed. It is time to look inward, because the inward view, the view of what the cell actually contains, is the view that matters most for any practical reckoning with the confinement. The Earth is, by any objective measure, a miracle of complexity. In the context of everything we know about the universe, the 2 times 10 to the 23rd power stars in the observable universe, the hundreds of billions of Earth-like planets that statistics suggest exist in the Milky Way alone, the 13.8 billion years of cosmic history during which physics has operated. The Earth is the one confirmed example of a world that has produced, sustained, and elaborated life to the degree of complexity that includes self-awareness, abstract reasoning, science, art, music, mathematics, and the capacity to ask questions about the nature of the universe itself. There may be others, almost certainly there are others, but we have not confirmed them, and the Earth remains the sole empirical anchor for the claim that the universe produces complexity at this level. The cell contains the only known example of what we are. It also contains, within its extended neighborhood of the solar system, resources and environments that humanity has barely begun to explore. We have sent robotic spacecraft to every planet in the solar system and to many of their moons. We have landed on the Moon, Mars, Titan with the Huygens probe in 2005, an asteroid with the Hayabusa and Hayabusa 2 missions and the OSIRIS-REx mission, and a comet with the Philae lander in 2014. We have flown spacecraft past Pluto, New Horizons in 2015, and out of the solar system entirely, Voyager 1 and 2. We have mapped the surfaces of Mars and Venus in detail, measured the composition of Jupiter's atmosphere, observed the geysers of Enceladus, and the methane lakes of Titan. And despite all of this, humanity has never placed a human being more than 384,400 kilometers from Earth, has never visited Mars with a crewed mission, has never drilled into Europa's ice, has never deployed a balloon in Titan's atmosphere, has never set foot on an asteroid, has never established any human presence beyond low Earth orbit since December 1972. The solar system, in other words, is not a cell that humanity has thoroughly explored and found limiting. It is a cell that humanity has barely entered. The difference between the cell of the solar system and the solitary confinement of a bare room is the difference between Earth and Mars, between Earth and Europa, between Earth and an asteroid belt with more metal than has ever been mined in human history. The cell is not empty. It is extraordinarily full, and the exploration of what it contains, the genuine scientific, human, civilizational project of understanding and ultimately inhabiting the solar system is a project of essentially unlimited scope, requiring centuries to millennia of sustained effort and offering discoveries, challenges, and possibilities that dwarf anything achievable in the next few hundred years of earthbound civilization. The psychological reorientation required is significant but not unprecedented. It is the reorientation that every generation of humans has had to make when confronted with a hard physical limit, the limit of a lifespan, the limit of a body's reach, the limit of a single mind's comprehension. Every human being is, in their individual experience, confined to a body and a lifespan. The universe contains 10 billion years of future time and trillions of light years of space that no individual human will ever experience. The response to this individual prison is not despair. It is the cultivation of what can be experienced within the bounds of a life and the contribution of that experience to something larger than any single life. The response to the civilizational prison is the same, scaled up. The cultivation of what can be known and experienced within the bounds of a solar system, and the contribution of that knowledge to something larger than any single civilization. The long-term project of understanding the universe, of mapping its contents and laws, of becoming the part of the universe that comprehends itself. This is not a small project. It is not a consolation prize. It is the actual project. The stars are not the project. They are the decoration. The project is here, on this planet, in this solar system, with this physics and this history and these questions that have never been asked before by anything in the known universe. The project is consciousness encountering reality and trying, imperfectly and persistently, and with great ingenuity, to understand it. That project does not require reaching other stars. It requires the full and honest engagement with the reality we actually inhabit. There is something else contained in the cell that deserves specific mention: time. The sun has approximately 5 billion years of hydrogen-burning lifetime remaining. 5 billion years is not a prison sentence. It is an expanse of time so vast that it makes the entire history of human civilization, from the first stone tools to the present, look like the first half-second of a feature film. In 5 billion years, the species that descends from us, if it survives, if it adapts, if it continues to evolve and develop, will be to us what we are to the first replicating molecules in the ancient ocean, unrecognizably transformed, incomprehensibly more capable, possibly not biological in any sense we would currently recognize if the history of intelligence continues along the trajectory of augmentation and eventual substrate independence that seems plausible from our current vantage point. The prison comes with a lease of 5 billion years. The inhabitants of the cell in year 4,999,999,000 may find resources within it, physical, intellectual, computational, that we cannot currently conceive. The strange comfort of the cell, therefore, is this: the cell is the universe for all practical purposes of any civilization within human reach of comprehension. The distances beyond the cell are real, the walls are real, the physics is real and unambiguous. But the contents of the cell, the Earth, the solar system, the 5 billion remaining years of the sun's lifespan, the resources and environments and questions, and possibilities contained within the accessible region of space-time are so vast, so rich, and so incompletely explored that the prison, properly understood, is less a prison than it is a universe, a smaller universe than the one outside. But still, in every practical sense that matters to the beings inside it, a universe. Chapter 13. The Long View. What the prison teaches about intelligence in the cosmos. Step back from the individual and the civilizational perspective and take the longest possible view. What does the universal prison of the speed of light tell us about the nature and fate of intelligence in the cosmos? If the prison is truly universal, if every technological civilization that arises anywhere in the galaxy is effectively confined to its home star system on any timescale relevant to the civilization as a continuous entity, then the cosmos is not a single community of minds sharing information and resources across the galaxy. It is a collection of isolated experiments, each running in its own cell, each developing independently, each reaching its own understanding of physics and mathematics and the nature of reality, each eventually measuring 299,792,458 meters per second and understanding what it means, each eventually confronting the prison. Some of those experiments succeed in the sense of producing sustained, complex civilization for long periods. Others fail by self-destruction, by resource exhaustion, by the ordinary catastrophes of planetary geology and astrophysics, asteroid impacts, supernovae within damaging range, host star instabilities. The ones that succeed are isolated from each other by the prison, unable to communicate on relevant timescales, unable to help each other, unable to share the discoveries and the losses that each accumulates across its history. There is a specific poignancy to this picture that is worth dwelling on. Somewhere in the Milky Way, perhaps in the 200 billion stars that we cannot currently image individually with enough resolution to detect Earth-sized planets, there may be a civilization that has already understood everything that we are in the process of understanding. A civilization that has solved the question of dark matter and dark energy, that has a complete theory of quantum gravity, that has mapped its own brain at the level of individual synapses, and understood the relationship between physical process and subjective experience, that has composed music and literature and philosophy at a level of sophistication we cannot currently imagine. And that civilization is separated from us by distances measurable only in light years, unreachable by any signal in any relevant time frame, and unknowable to us except as a statistical probability. We will never benefit from what they have learned. They will never benefit from what we have learned. The discoveries of each civilization are locked within its cell, unable to propagate across the prison to the other cells, unable to compound across the galaxy into a collective intelligence that transcends any individual civilization's lifespan. The universe produces minds and then separates them by distances they cannot cross. And the minds develop in isolation, and the isolation is permanent. But there is another way to read this. The isolation means that each civilization's understanding of the universe is genuinely its own, developed from first principles in its own context, with its own tools and its own questions. The isolation is not just loss, it is also independence. The universe is not running a single, unified experiment in intelligence. It is running billions of independent experiments, each starting from the same physics and the same basic chemistry and the same gravitational collapse into stars and planets, but each developing along its own contingent path, shaped by its own evolutionary history and its own planetary environment and its own cognitive architecture. The diversity of what those billions of experiments might produce, the diversity of minds, of mathematics, of art, of philosophy, of understanding, is something that would be lost if all of them were in communication. The prison that keeps them apart is also the mechanism that preserves their distinctiveness. This is not a fully comforting thought. The isolation is real and the loss is real, but it situates the isolation within a larger picture of the cosmos, as a place that generates not just matter and energy, but minds. A place where the same fundamental physics that produces stars and galaxies and cosmic web also, in small, warm, wet corners of specific planetary surfaces, produces consciousness and curiosity and the astonishing capacity for self-reflection. The prison is the price of this diversity. The walls are what protect each experiment from being overwhelmed by the others. And there is one final thing to say about the long view that has not been said yet. The prison is not eternal. In approximately 5 billion years, the sun will exhaust its hydrogen fuel and expand into a red giant, eventually engulfing the inner planets, including Earth. The cell will be destroyed, not breached, not escaped from, but consumed by the energy source that has sustained it. Whatever intelligence exists in the solar system at that point, whether it is still biological humanity or something descended from humanity beyond any current recognition, or something else entirely, will face that end. Either it will have developed the technology to move, not to other stars necessarily, but within the solar system, to the outer planets and moons that will remain habitable as the sun expands, or it will not survive. The question of whether civilization within the solar system can persist across the 5 billion year remaining lease, and whether whatever exists at the end of that lease can navigate the transition to the outer solar system, is the longest horizon challenge that the prison presents. It is not a challenge for us. It is a challenge for whoever we eventually become. But knowing it exists, knowing that the prison itself has a lifespan, is another piece of what it means to understand, fully and honestly, the situation we are actually in. Conclusion. So here is what the prison of the universe actually is. It is 299,792,458 meters per second, the speed of light, the maximum speed at which any object, any signal, any piece of information can ever travel. It is a number fixed at the formation of the universe, embedded in the structure of space-time itself, confirmed by a century of precision measurement and immune to any technology or ingenuity that any civilization could ever develop. It is not a challenge to be overcome. It is a feature of reality to be understood. It is 4.24 light years to the nearest star, a distance that, at the fastest speed any spacecraft has ever achieved, would take 66,000 years to cross. At any speed achievable by nuclear propulsion, the most energetically credible future technology, it would take 40 to 80 years, requiring energy inputs that dwarf the output of entire nations, with radiation hazards that are unsolved and possibly unsolvable, and with the consequence that the traveler who departs does not return to the world they left. It is 100,000 light-years across the Milky Way, a distance that makes even the fastest conceivable travel take geological epochs to complete. It is 2.537 million light-years to Andromeda, 3 times the time it takes to cross the Milky Way. It is 46.5 billion light-years to the edge of the observable universe, a distance that makes human timescales vanish into the noise. It is a dark energy wall, currently at 16 billion light-years, beyond which no signal sent today will ever arrive, contracting the accessible universe in the slow, inexorable tightening of an expanding space-time. It is a cosmic event horizon that is carrying the observable universe's galaxies, one by one, beyond the boundary of causal contact. Until 1 trillion years from now, the prison has contracted around the local group like a sealed room, and all evidence of the broader universe has faded beyond detection. And it is, simultaneously, a solar system of extraordinary richness. 8 planets, hundreds of moons, millions of asteroids, the ice and methane of the outer solar system, the liquid water ocean of Europa, the ancient geology of Mars, the thick atmosphere of Titan, the geysers of Enceladus, the asteroid belt of essentially unlimited metals and minerals, all within reach of human technology on timescales of years to decades. It is an Earth of incomprehensible biological complexity, 4.5 billion years of geological history, 3.8 billion years of unbroken biological evolution, 8.7 million species, and the specific configuration of chemistry and physics that produced consciousness and curiosity and the capacity to ask the question of its own confinement. The universe built a prison. It built it out of the speed of light and the distance between stars and the dark energy that pushes everything farther apart with time. And it put inside the prison a species that could measure the walls, understand the physics, calculate the distances, derive the limits, and sit with the knowledge of its own confinement with something approaching clarity. That species looked at the walls and understood them. And then it turned around and looked at what was inside the walls. And what was inside was not nothing. What was inside was everything it had ever known, everything it had ever loved, everything it had ever built or broken or mourned or celebrated. A planet with oceans and mountains and weather and seasons. A sun that has been burning for 4.6 billion years and will burn for 5 billion more. A solar system of moons and rings and ice and rock and ancient craters, and the tracks of the 12 people who once walked somewhere other than Earth. A sky full of stars that are permanently out of reach and permanently available for observation, for measurement, for understanding. A universe that can be known, not traveled, not colonized, not escaped, but known through light and mathematics to extraordinary depth and precision. The prison is real. The walls are real. The physics is unambiguous, and the distances are what they are. And inside the prison is the only known place in the observable universe where anyone has ever looked at the walls and understood them. That is not nothing. That is against all the odds and all the emptiness and all the silence, everything